Continuing on with our discussion of Numpy, creating arrays by hand is, like I said, one way that we can create arrays. It's not a very efficient way unless it's a pretty small array to begin with. But one of the things that you might need to do throughout your data analysis kind of processes is to create what we call kind of standard arrays or sequential arrays, or there's very specific types of arrays that you might want to create. And Numpy has a number of built-in functions to be able to do these kind of standard array types very quickly and efficiently. Okay. And so there are two different ways to get what we call a sequential array. So let's say you want to start at a number and end at a number and have a certain number of divisions or a certain number of steps. Numpy has functions for that. So the first one is what we call the arange function. Okay, so np.arange, and the kind of inputs that this needs in its parentheses are basically the start value, so that's the number you want to start with, the end value, and by which, like how many steps are in between. Okay, so do you want one step in between? Do you want two steps? So you want to go from, with one step you could go from 0 to 1. With 2 steps it would be 1 to 3. Okay, 5 steps would be 1 to 6. Okay, so you can make a very specific array of whatever size you want. Okay, and Python will automatically kind of figure out the array size for you with this kind of simple function. So arange, start value, end value, and step. Okay, so if I run that, okay, you can see up here we get this array A here. And so here you can see I've done start at 1, go to 100, and by a step of 3. Okay, so 1, 4, 7, 10, 13, 16, 19, 22, all the way up to, in this case, 97. Okay, so one thing to remember about the arange function is that the end is what we call exclusive. So we're not actually going all the way to the end. Okay, we're going to the step value that's before the end. Okay, so think about that as like the end value minus the step will be the last value in your array. If you wanted to get the value, in this case of 100, okay, in your array, what we'd actually have to do is kind of preemptively tell Python that we actually want it to go past 100 and include it in here. And we're going to go to, since we're by step 3, okay, we'd actually put in 103 here. Okay, so if I do that and we look at this, okay, again, starts the same, 1, 4, 7, 10. But then the very last value, okay, instead of stopping at 97, it's added another row in here to give us that value of 100. Okay, so that's just something to remember if you're using the arange function, is that it's exclusive. Okay, another way to create a sequential array, okay, is using what's called the Linspace command. So this is a linear, we call a linear space array. And so this actually does something a little bit different than arange in that it still wants a start and an end value. Okay, so we're going to say, in this case, we're going to start at 0 and we're going to go to 1. Okay, and what the last variable input here is going to be the number of divisions that we want in that space. So from 0 to 1, I want to divide that space and get the numbers in 6 equal divisions. Okay, or 5 equal divisions, or 10, or 100, it doesn't really matter. Okay, but this is a way to kind of take a start and an end point and get the equal division spaces between it. Okay, so if I run this, you'll see what that looks like. Okay, so I start at 0, go to 1, and then basically I want to get 6 equal spacings. And so in our array here, you can see we go from 0 at our start to 1 at the end. And then we have basically an array of size 6 with, in this case, 0 to 1 divided by 6 gives us a nice even 0.2 spread in here. Okay. If you wanted to get more divisions, okay, let's say we wanted, I don't know, 32 divisions, okay, and we reran that, okay, now you're going to see kind of a messier array, okay, but again, we're going to start at 0 and go to 1, and then each one of these steps in here is basically a 32nd of that value, okay. So Linspace is a little bit kind of harder to wrap your head around than arange, but they're both useful in their own way. Okay, so like you saw, Linspace does kind of the opposite than arange. So in Linspace, the end is inclusive. So from the start to the finish, it will include both values. But you can actually tell it to not use, you can make it exclusive with an extra input here. Okay, so in this case, if we said 0 to 1 divided by five spaces, but not including the last point, so the endpoint equals false, okay, if we run that, okay, as the array C here, okay, you see we get 0, 0.2, 0.4, 0.6, 0.8, just like we did above with a division of 6, but we're missing the 1 there. And it's just something you might want to do. It's an option. Another thing that you are likely to want to do is to create a, say, a blank array, okay, or an array that's kind of got placeholder values in it. And there are two ways that you can do this. And there are what are called 0 arrays and a ones array. Okay, and so these are basically arrays that are filled with either all zeros or all ones. And so the way that we do this, okay, is so zeros is our variable name, and then the function is np.zeros, okay, and then we have to do an open parentheses, and then another open parentheses to tell us, or to tell the software how many rows and columns we want. Okay, so open parentheses for the zeros, and open parentheses before our rows, comma, columns, close parentheses, close parentheses. Okay, this is, again, that specific kind of tuple list inside or outside brackets, or outside parentheses here. Okay, so in this case, I'm going to create a zeros array with 4 rows and 7 columns that's just filled with zeros. Okay, so there it is. Okay, so 4 rows, 7 columns, just full of zeros. And this is a good way to create kind of a blank placeholder array if you want to go in and kind of manipulate individual values or put in values in specific places. A zeros array is a good place to kind of start. Okay, the second one is, again, like a ones array is just the same thing filled with ones. So in this case, I'm going to do a ones array that's 3 by 3, so 3 rows, 3 columns. And there you can see those values as well. Okay. Some of these are useful in statistics, but again, I usually use a zeros array as just kind of a blank placeholder array. Okay, if I know how big I need to make an array, I can fill it with zeros and then fill in the values as I need. Okay, another specific one for certain types of statistics and math operations is what's called an identity array. Okay, and this is where you have a 1 on the diagonal, so starting in the top left corner going to the bottom right. Okay, again, this is for a lot of times for linear algebra, but some other specific types of math as well. And so this is using what's called the I command, so EYE, like your eyeball, but it stands for identity. Okay, and so if you run that, basically this will create a square array with the equal number of rows and an equal number of columns. So all you have to do is tell it how many rows or columns you want. And so this will be a 5 by 5 array with, again, that, which is kind of that identity parameter to it. So zeros in most of it, and then ones down the diagonal. Okay. Another one that we'll use quite a bit for just kind of playing with data and generating arrays that we can kind of manipulate is to build up what we call a random array. Okay, and so there's you can get a one-dimensional array by just telling Python that you want an np.random.rand. Okay, this is kind of a double jump down in functions. Okay, so but np.random.rand, and then in this case, if we just said 4, we'd get a one-dimensional array with 4 values. And then if we add in a rows and columns, okay, we can get a two-dimensional array. Okay, so if we run those over here, you can see that we get, in this case, the random values that we get are from 0 to 1. Okay, which is kind of a classic way random numbers are generated. So that first one is just a one-dimensional array with 4 values. The second one here is a 3 by 4 with random variables stuffed in there. All right, so next we're going to talk about array indexing and what we call slicing. Okay, so for this, I'm going to clear out my variable explorer just so we have a fresh space to work in. Okay, and so in this case, I've already got Numpy imported over here. I just had it down here just in case. So in this case, here's just one more kind of additional array creation technique. Okay, but another thing that you need to keep in mind, okay, for Numpy arrays is that arrays are what we call single data type. Okay, so you can only have arrays that are integer or float or string. Okay, they can't be mixed. Okay, so if you try to mix them, it's going to cause problems. Okay, once we get into pandas data frames, that's where we can start to mix data types in our different columns of our data frames. But for Numpy arrays, we have to keep kind of our variable types exclusive. Okay, so the example that I have here is that if you typed in the function, the arange function, and you said 1.0 to 17.0, you would get a float array. Okay, if you typed in np.arange 1, 17, in that case you'd get an integer array. Okay, and so this doesn't really affect you too much, but it is something to just be aware of, is that you do have to be conscious of those data types. Okay, so again, one more kind of array creation trick before we jump into slicing, okay, and indexing, okay, is that if we create, one way to get a two-dimensional array, okay, is to take a one-dimensional array and call what we would call reshape it. Okay, so in this case, I'll create an array A, okay, within the A range, so from 1 to 17. Okay, so in this case, I've got 1 to 16, okay, 16 values. Okay, and so if I print that down here in my console, you can see those values there. Now, what I can do is say I want to create a second variable here, B, but I want it to be a kind of a copy of that one that we just created up here, A. Okay, so in this case, I could say A, and what I want B to be is actually a 4 by 4 array, so a two-dimensional array, not a one-dimensional array. Okay, so I can say A dot reshape, okay, and then how I want to reshape that. Okay, so in this case, I want to do 4 by 4 to make it square. Okay, I could do 2 by 6. I could do 6 by 2. Okay, these numbers do have to match the number of values you have in your original array. Okay, I couldn't reshape this into a 5 by 5 because there's not 20 values or 25 values in this original array. Okay, there's only 16. So in this case, 4 by 4 gives us 16 cells in a two-dimensional array. Okay, so that gives us, here you can see, so 1, 2, 3, 4, 5, 6, 7, 8, all the way to 16. Okay, so that same A array reshaped into this second B array. Okay, so the way that we do indexing, okay, and we talked about that earlier, okay, and this is very similar to the way we do string indexing or the way we do list indexing, okay, is that we use this bracket notation to extract out kind of the individual values that we're interested in. Okay, so in this case, if I want to get the third index out of that A array, okay, so in this case, if we look at that, the third index here would be the value 4. Okay, so A open bracket 3 is the third index. Okay, and if we use the print command here, we just get that value 4. Okay, in a two-dimensional array, like we talked about, we use rows and column numbers to specify those individual cells. Okay, so in this first example, if we go 2, 2, 2, okay, that's the second row here, okay, and the second column index over here. Okay, so that would be 11. And sure enough, okay, if we print that value, that is 11. Okay. If we print the third 0, 3, okay, we're going to take the 0 row, the first first row here, the 0 index, and the third index in the column, okay, which would be a value of 4. Okay, there it is. Okay. The nice thing about this, okay, and this is something you will likely do quite a bit, okay, is that you can actually reassign values in an array, okay, based on their index. Okay, so in this case, if I wanted to change a value in the 0 row and the second column index, okay, which in our case is 0 and 2, okay, would be this value 3 currently. Okay, what I can do is actually tell Python to look in array B, the 0 column, or the 0 row, the second column, or the 2 column, and then I can set that value equal to a new number. Okay, so in this case, I'm going to change 3 in that array to 79.45. Okay, so if we look in our B array here, okay, you can see the 0 column, or the 0 row, column number 2 here, okay, has been changed to that new value. Okay. So that's definitely something that you guys are likely going to have to do at some point, is that you're going to want to go in and actually change individual array values. And so this is the way to do it. Okay, with this, your array, open bracket, the index that you want to change, and equals whatever value you want to stick in there. Okay. So another thing that you can do is what we call slice an array, okay, or select a range within an array. Okay. And so the way that we can do that is that we use a similar kind of format to our indexing. Okay. But instead of just asking for a specific cell number, we can actually ask for a range of values. And the way that we do that is through using colons in our kind of selection criteria here. Okay. So in this case, we're going to look at the A array, which is the one-dimensional array. Okay. And what I'm going to do here is pull out starting at the 0 index, okay, and going to the second index. Okay. Now again, this is an example where the last value here is exclusive. Okay, so we'll go from 0 up to 2, but not include that 2 index. Okay, so if we look at this in a practical sense, okay, we're going to go from 0, we're going to include the 1, okay, we're going to go up to 2, but not include it. So if we use this command right here, we should get out the values 0 or 1 and 2 out of this. Okay, so that's pulled out 1 and 2. Okay, if we wanted to do something else, if we wanted to get a different range, okay, so print A, open bracket, and let's say I want to get like towards the end, okay, I could do something like 13 to 16. Okay, so A, open bracket, 13 to 16. Okay, and if I run that, okay, that gives me the last few digits out of that array. Okay. For the other thing that you can do with these as well is that you can actually skip values. Okay, so just like we did with the A-range creation technique, okay, you can actually specify a start and end and a step value in here. And so again, you would do that with these colons to specify those different start, end, and step. Okay, and so in this case, we could go from 0 to, say, the 10 index, okay, by steps of 3. Okay, and that would give us 1, 4, 7, and in this case 10. Okay. If for some reason you wanted to just get every third value out of an array, you don't have to specify the start and the end. Okay. If you just put in a blank, a blank colon, and then the step, so colon, colon, step value, okay, that'll just get you all of that for the entire array. That'll just give you every third value. Okay, so that can be kind of handy as well. Okay, in a two-dimensional sense, okay, again, we're just kind of add in the dimensions that we want. Okay, so in this first range, we're going to look at rows. So from the 1 index to the 3 index, okay, and then comma. In this case, we want the 2nd to the 3rd index in the columns. So if we run that, okay, in that case, it only gives us 2 values. Okay. Another trick that you can use in selecting values is that if you just use, again, kind of a blank colon in either position in the rows or the columns, that'll select either all the columns in a row or all the rows in a column. Okay. So this first example is B colon gives us all of the rows in the index 2 column. Okay. So if we run that, you can see we get 79, 4, 5, 7, 11, and 16 or 15. Okay, so that's all of these values right there. So all of the rows in this 2 index column. Same thing for this one. If we choose the 3rd row and all the columns, okay, that's 13, 14, 15, 16. And sure enough, in our 3rd index here, if we looked at all the columns, those are those values there. Okay, so one thing that you do have to be careful of, okay, in Numpy, if you are doing things like reshaping or copying, is that sometimes the arrays actually are kind of what we call linked in memory. Okay, or one array is what we call just a view of the original array. And so I'm not going to run this code right here, but if we look up in our variable explorer, okay, you remember up above we changed this value of 0, 2 to 79, 4, 5. Okay. Well, that's all well and good, but if I open up the A array here, and you may have seen it when I opened this up earlier, okay, you'll actually see that this value here, okay, which corresponds to the copied value here, actually changed automatically. Okay, I can show you that again if I just go in my console, okay, and type in B, and let's do the last value here. Okay, so that's an index of 3, 3. So 3rd row, 3rd column, okay, equals, we'll just say 100.5. Okay. So you have to close and reopen this, but there it is there. Okay. And if I open up my A array, okay, and scroll down to the bottom, you can see that it's changed here as well. Okay, this is just something to be aware of. It's not necessarily a bad thing, but if you are doing kind of reshaping or copying of arrays and you're making changes to individual parts, you may essentially corrupt your original data set with these changes. So it's just something to be kind of aware of. So one way around that is to use what's called the copy command. Okay, and so this will actually make a kind of a copy that is distinct from the original array. and then you can actually change stuff without having to worry about it changing the original array. Okay, so we've already talked about reshaping a little bit. So again, we can start with a one-dimensional array and change the shape. Okay, and so in this case, again, this is just that same example above. But what I want to show you here is that if we try to reshape this in a strange way, okay, so actually I'm just going to re-initialize this variable so it's 1 through 17 so we can see it again. Okay, and B is reshape 4 by 4. Okay, what happens if I do a reshape that doesn't match the number of values that I have in there? Okay, so if I do C equals A dot reshape, and let's do 10 by 6, that's way more values than we have in our original 16, length 16 one-dimensional array here. And so if we do that, we're going to get an error. Okay, so it says cannot reshape array of size 16 into a shape of 10 by 6. Okay, so 10 by 6 is way more values, and so it won't do it. Okay, so that's just, if you get into some problems with this, or if you're having trouble with this and you're getting this error, it's basically you're trying to reshape a smaller array into a bigger array, or actually the other way around works as well too. If you're trying to go from a big one to a small one, it should probably yell at you as well. Okay, there is some other commands in here that I'm going to kind of skip over for now. We'll get back to these as we need them, but you can resize an array. Okay, so you can make it smaller. So if you wanted it, in this case, if you wanted to take this is a 2 by 3 and resize it to a 2 by 2, or make it bigger to a 6 by 6, you'd use the resize command. You can do what we call transpose or flip arrays. Okay, and so this is, transposing is actually taking the columns and making them the rows, and making the rows the columns. Okay, it's kind of a complex task. Or flipping the bottom values to the top, or the left values to the right. So these are kind of more advanced commands. We'll come back to these as we need them, or if we need them in the future, but you can do that. So you can, again, things like transposing, flipping up to down, or flipping left and right are fairly straightforward. Okay, the last things that I want to look at real quick today are, and we mentioned this earlier this week, is the idea of missing data or blank cells in our arrays. And so the way that we have to do this, again, is that 0 does not mean nothing or blank data. Okay, 0 is a data value in most instances. Okay, and so in this case, what we have to do is actually use a kind of specific terminology for blank values. Okay, and in Numpy, we can actually assign blank values with a kind of a constant, if you want to think about it like that, called np.nan. Okay, and so nan stands for not a number. Okay, and so that's essentially just a blank cell. Okay, so if I was going to create an array here, this is just a 2 by 2 array with 1, 2, 3, and a nan value. Okay, and if we open that up in here, you can see we have 1, 2, 3, and nan. Okay, so nan is essentially, think about that as a blank cell. So this becomes important again if you're doing some math, which we'll talk about next, on an array. Okay, one kind of, we call it reduction technique for an array, is to say I want to get the mean value of all of the values in this array. Okay, and so if I take the mean, just the straight mean value of this array, okay, or do the whole thing. Okay, so if I take the mean of that whole array, okay, then I'm going to get a value that you can see up here in my variable explorer of nan. Okay, so there's a missing value in there. It's blank data. So if I try to take the mean of all of that, it's basically going to return not a number value, okay, because it can't do anything with it. And so in certain cases, you do have to use a very specific kind of function in NumPy. In this case, it is a function called np.nanmean, okay, where this basically ignores the nan values and just takes the average of the values that are actually valid. Okay, so if I run that, okay, the nan mean value here in my variable explorer comes out to 2. Okay, so if we took the average of 1, 2, and 3, okay, the average of those 3 numbers is 2. Okay. If you want to assign nan to a cell, let's say you're going through and you're saying, okay, I want to pick out a certain cell. I actually want to turn into a blank cell. Okay, the way to do that is, again, just using the index notation that we've used above. Okay, so in this case, like cell, or the second index, second row index, fourth column index, you can set that equal to a nan value, which is pretty straightforward. So that's going to do it for this video. In the next one, we're going to look at how to do array concatenation and some basic math functions with arrays.